Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concept in our today's mathematics bridge course classes. So children, are you all ready with your book and pen? So let us start our session children. So today we are going to learn about symmetry. By the end of this session, you will be learning line symmetry, lines of symmetry, rotational symmetry and order of rotational symmetry. So children, let us start with line symmetry. What do you notice on your screen children? Yes, you are right, it's an ambulance, isn't it children? You might have seen ambulance on the roads, right? So in this ambulance, if you notice children, the word, it is written in reverse order. Have you ever noticed this children? If you notice the same word in a mirror, when you are traveling in a car or maybe a bike or some other means of transport. Now this word which is written in reverse order, you will be able to see it in a perfect way, that is easily you can read ambulance. Now let us see why actually or what exactly this ambulance looks like. Now this is the word which is written on the ambulance. Now if you consider this is the mirror, now the image obtained will be exactly like this, that is ambulance. Now can you notice any differences here children? Yes. Now if you notice here letter A and A both are looking same way, isn't it children? Now even M also if you notice, they are looking in the same way, but notice children here B and here they are exactly in reverse order, isn't it children? So like that you can notice some more letters in this word also. Got it children? And this ambulance which is written this way, we generally call it as mirror images. Suppose this is the actual word, then in the mirror it looks like this, and we call these letters as mirror images of these letters. So now let us see the mirror images of English alphabet. Let's see children. So I am taking a mirror over here, I am taking the first letter A. Now what will be the image? Yes, it looks exactly like A only children. Let us move on to our next alphabet, that is B. Now what about its image children? Yes, can you notice the difference children here? It is completely reversed here. Even when A is reversed it looks same, but B it looks entirely different. Now take a look at the other alphabet, that is C, and the mirror image of C you can notice on the screen. Now children, we have seen the mirror image of some of the letters in English alphabet. Now I want you to complete this small activity which I am going to show you now. Now here are the alphabet and the mirror images. Now children, can you match them properly? Let us see the first one, D. That's right children. So the mirror image of D looks this way. Now what about R children? Yes, you are right once again children. Now let us move on to next letter, that is P. You are absolutely right children. Then the letter Z, yes, you are again right children. And M, it looks as it is, there is no change. So children, I hope you have understood how to write the mirror image of letters in English alphabet. Now children, take a look at the images shown on your screen, a smiley and a beautiful architectural, say a fort or maybe a building, isn't it children? Now these two objects, that is if you consider a smiley or this monument, they are said to be symmetric. Now what actually is symmetric? Now take a look at this beautiful butterfly. If I am going to draw a straight line as shown on your screen with these red dotted lines, now what exactly happens here? Now when I fold either the left side part or the right side part, one over the other, if I place it, they look same, or I can say they are congruent. Then such figures are said to be symmetric. So children, take a look at this person, and even if you draw a line as shown on your screen, and if you fold the image of this person along this dotted line, both the sides of this line gets I mean to say they overlap on one another. So, such figures we generally call it as symmetric figures. Now, here these two figures which are shown, they look beautiful because they are symmetric. Not only that children, these two, any object which is symmetric always looks beautiful. Now, let us see what is meant by symmetry. Now, in this class we are going to learn about two types, that is line symmetry and rotational symmetry also. So, children, first we will learn about the line symmetry. Now, if you consider these two images that we have already discussed, if the figures are folded along this dotted line, now if you notice this butterfly or this person and there is a dotted line. Now, if you are going to fold this figure along this dotted line, now each part will coincide with the other exactly. Such type of figures are said to have line symmetry. Understood children? So, we are going to draw a line, and when we fold along that line, if both the parts exactly coincide, then we say these two have line symmetry, and the line along which the paper is folded is called the line of symmetry or axis of symmetry. So, we have noticed children here, isn't it? So, here these are the two lines we have drawn. Now, these lines along which we are folding, so these lines are called the lines of symmetry, or we may even call it as axis of symmetry. So, children, now let us consider a car here. Now, if I draw a line like this and if I fold along this line, does the both parts coincide exactly? No, that means they are not symmetric. Now, let us draw another line like this and fold along this line now. Yes, they exactly coincides. I can say this is a symmetric figure. So, children, the lines of symmetry can be horizontal, vertical or diagonal also. So, here in this case we have seen this figure is symmetric about horizontal line, but when we have drawn a vertical line, it is not symmetric. So, that is why children, when you are checking whether the object is symmetric or not, you need to draw a vertical line, horizontal line and also diagonal, and then decide whether the object is symmetric or not. Got it children? Now, let us consider about the symmetry of alphabets. Now, we will take the first letter A. Now, I am going to draw a vertical line now. Now, if I fold along this vertical line, then these two parts exactly coincides. So, I can say yes, it is symmetric, and it is symmetric about this vertical line, isn't it children? So, I say this line as vertical line of symmetry, but if I draw a horizontal line and fold along that line, it will not be symmetric. Got it children? Now, let us move on to our next letter, that is B. Now, let us draw a vertical line. Now, along this vertical line if I fold, it will not be symmetric, isn't it children? Whereas, if I draw a horizontal line and fold along this horizontal line, then both the sides get coincided. That means, this line is going to be the line of symmetry, or I can say simply horizontal line of symmetry. Got it children? So, what do we conclude? Both A and B have one line of symmetry. Now, let us move on to our next alphabet children, that is C. Now, let us draw a horizontal line and fold across this line. Now, what do you notice on folding this? Yes, you are absolutely right. It is symmetric. So, this is horizontal line of symmetry. Now, let us consider letter G now. Now, if I am going to draw a vertical line and fold along this, it will not coincide these two parts. Now, let us draw a horizontal line. Now, if you fold along this also, they will not be symmetric. And let us take a slanting line like this and check whether it is symmetric or not. No, even then they will not coincide. Then I can say that G is not symmetric. So, what do you conclude children? Yes, C has one line of symmetry, whereas G has no line of symmetry. Got it children? So, children, till now we have seen what a symmetry is and we have drawn lines of symmetry of letters in English alphabet, and also we have seen how many lines of symmetry can be drawn, isn't it children? Till now we have seen only one line of symmetry. So, does all the letters in English alphabet have only one line of symmetry? Let us check this children. So, let us consider the letter H. Now, I will draw a horizontal line, and when we fold across this horizontal line, again it is symmetric. I will draw another line, that is a vertical line, and if you fold along this also, it is symmetric. So, this is one vertical line of symmetry, and we have already a horizontal line of symmetry. That means, we have two lines of symmetry for this letter H. That means, what we can say children? Yes, the letters in English alphabet may have one line of symmetry or more than one line of symmetry, or even may not have line of symmetry also. Now, let us check for multiple lines of symmetry for some geometrical figures. Let us consider a rectangle as shown on your screen children. Now, I am going to draw a vertical line like this, and if I fold along this vertical line, now what do you notice children? Yes, it gets easily coincides is both the parts. So, I can say it has one vertical line of symmetry. Now, if I draw a horizontal line and fold along this horizontal line, then also it will be symmetric, and that line we call it as horizontal line of symmetry. And if I draw a diagonal line like this, a diagonal, and fold it, it will not be symmetric. So, I can say a rectangle has two lines of symmetry. Now, let us move on to our next geometrical figure children, that is a square. So, look at this square shown on your screen children. Now, if I draw a horizontal line as shown, then if you fold across this line, what happens children? Yes, it gets coincided both the parts. And if I draw a vertical line also and fold along that line, yes, it will get coincided. That means, this is the vertical line of symmetry, and the other one is the horizontal line of symmetry. Now, let us draw a diagonal over here. Yes. Now, when I draw a diagonal over here and I fold across that, or if I draw one more diagonal here and fold along the diagonal, then you will see that square is symmetric about that diagonal also. So, we call it as diagonal line of symmetry. So, altogether how many lines of symmetry are there children for this? Yes, it has 4 lines of symmetry. That means, a square has 4 lines of symmetry, of which one is horizontal line of symmetry, the other one is a vertical line of symmetry, and then 2 diagonal lines of symmetry. Got it children? Now, let us look at this figure shown on your screen children. Now, does this image which is shown is symmetric? If at all, just draw the lines of symmetry. So, children, I am going to draw a line as shown on your screen. Yes, how many lines I could draw? Yes, I have drawn 3, and when I fold along these 3 lines, when I take this line and I fold along this line also, it would be symmetric. If I take this line and I fold it along with this line, it will be symmetric. Like that, I can have 3 lines of symmetry for this figure. So, children, till now we have seen the symmetry of letters in English alphabet, and also we have seen multiple lines of symmetry, and even symmetry for geometrical figures also. Now, children, I would like to show you a small activity or the application of symmetry in our daily life. So, children, take a square paper here as shown on your screen. Got it children? And as we have seen, a square has how many lines of symmetry children? 4 lines of symmetry, right? Now, I am going to fold along this vertical line children like this. Now, if you notice, yes, you can see a line over here. You can see, right children? Yes, this is one line of symmetry. Now, if I fold it horizontally like this, then you can notice one more line has formed here, right? This is the horizontal line of symmetry. Now, these are the 2 lines of symmetry. Now, apart from this, even if I fold along this diagonal also, like see one diagonal over here like this, it looks exactly symmetric. Now, I will just fold this, then again one more fold, again it looks like a small square, then I am going to fold along this diagonal also. Now, take a scissor children, and children, you need to be very careful while handling the scissor. Okay? And it is better if you can do this activity in the presence of your elders. So, now I am going to cut this into a different geometrical shapes. So, I have cut this one in this way, and then I am going to have one more design like this. So, you can cut it into any geometrical shapes of your choice, children. You can use your complete creativity. Okay. So, I have done this way. Okay. Now, just unfold this, children. Now, when I unfold this, you can notice a beautiful pattern. You can see a beautiful pattern is formed here. So, if you notice, this is a symmetric object, children. So, I hope you understood this activity, children. So, lines of symmetry for regular polygons. So, children, let us have a look at the images shown on your screen. Can you identify the images shown on your screen? Yes, they are called polygons. But what are polygons, children? A polygon is a simple closed figure formed by 3 or more line segments. So, if you notice these 3 figures which are shown, they are all closed figures, isn't it, children? And all these are formed by using line segments only. These figures are called polygons. Do you know what are regular polygons then? So, a polygon in which all sides and all angles are equal is called a regular polygon. Now, let us see what actually a regular polygon is. So, take a look at this. If you notice the first one, the triangle, all the sides are equal in this triangle. So, it is called an equilateral triangle. So, it is a regular polygon. And if you consider this square, all sides are equal. So, it is also a regular polygon. And then the last one, if you notice, all the 6 sides are equal. So, it is hexagon, right. So, since all 6 sides are equal, I call it as a regular hexagon. So, let us see the lines of symmetry for these regular polygons. So, take a look at the triangle shown on your screen, an equilateral triangle, and I am going to draw a vertical line as shown, and there one more through another vertex, and through the other vertex also I am drawing. So, through these 3 vertices I have drawn 3 lines, and whenever you fold along these lines, then both the parts coincides exactly. That means, this equilateral triangle is symmetric and it has 3 lines of symmetry. Got it, children? Now, take a look at another one, that is a square. Now, I will draw a horizontal line, a vertical line, and we have seen already it has one vertical and one horizontal line of symmetry. Then we are going to draw 2 diagonals, and it has 2 diagonal lines of symmetry. So, in all, a square has 4 lines of symmetry. So, children, till now we have learnt about symmetry, and also we have learnt about line symmetry, lines of symmetry or axis of symmetry. Now, children, let us move on to rotational symmetry also. Now, consider the image shown on your screen, children. Now, I am going to take this image, and you can notice there is a fixed point in this image, isn't it, children? Now, when I am going to rotate through certain angle, so I have rotated from 0 degrees to 90 degrees. Now, does these 2 figures look same? No, they do not look, right. That means, from 0 to 90 degrees, I never got the same figure what initially I have, isn't it, children? I always got a different figure. Now, let us move from 91 degrees to 180 degrees. Now, after moving to 180 degrees, now what do you notice here, children? Yes, this figure which is obtained after rotating 180 degrees and this starting figure both look same, isn't it, children? So, at exactly 180 degrees we got the same figure. Now, let us rotate it further from 180 degrees to 270 degrees. Now, do you notice the same figure or a different one? Absolutely right, you noticed a different figure in all these rotation. Now, let us rotate further 90 degrees, that is up to 360 degrees. Now, after moving up to 360 degrees, you got the same figure again. Can you notice, children? Yes. So, at 360 degrees also we got back the same figure. That means, when we started rotating from 0 degrees till 360 degrees, that is one complete rotation, we got the same figure twice, isn't it, children? Then such objects are said to have rotational symmetry. So, this object has rotational symmetry. So, what actually is a rotational symmetry? If we rotate a figure about a fixed point. Now, this figure we have rotated about this fixed point, isn't it children? Again that to certain angle. So, 1 degrees, 2 degrees, 3 degrees, so on, up to 360 degrees we have moved. So, what happened? We got a figure which looks exactly like the one which we have taken. Then we say this object or this figure has rotational symmetry. Got it children? Now, let us understand more about rotational symmetry of alphabet. Now, I will take letter H, okay. Again I will rotate through 90 degrees. Did we get the same H children? No. Now, let us rotate through another 90 degrees, that is total 180 degrees. Yes, we got the same H, right children. Now, let us further rotate through 90 degrees, that means 270 degrees. So, we did not get the same image or same letter H. Then we rotate it through another 90, that is total 360 degrees. So, what did you notice? Yes, we got the same letter H. So, the minimum angle rotation of a figure to get exactly the same figure as original is called angle of rotational symmetry or simply angle of rotation. So, let us understand this statement children. So, when you have rotated this exactly at 180 degrees, you got H, right children. Again from 181 to 360 degrees you have moved. Again at exactly 360 degrees you got back the same letter H, isn't it children. Now, this angle for the first time where you got the same figure as this one is called the angle of rotational symmetry. That means, here I can say the angle of rotation is 180 degrees or angle of rotational symmetry is 180 degrees. Even though we are getting another same image when you rotate to 360 degrees, but for the first time when you are getting at 180 degrees. Now, that angle is called the angle of rotation. Got it children? The number of times a figure rotated through its angle of rotational symmetry before it comes to original position is called order of rotational symmetry. That means, I started from 0 degrees and I have completed one rotation, that is up to 360 degrees. So, how many times I got this letter H children? Same letter H? Yes, I got twice, isn't it children? Once at 180 degrees, the second one is at 360 degrees. Then I can say that the order of rotational symmetry is 2, because we got it 2 times this letter H. Now, let us take the same square here and I will rotate through 90 degrees. What do you notice children? Yes, you got the same square, and again I will rotate through another 90 degrees, that is total 180 degrees. Then also you got the same square. Now, let us rotate to further 90 degrees, that is 270, then also you got the same square. Now, let us complete the rotation, that is 360 degrees, then also you got the same square. Now, children, can you guess what is the order of rotational symmetry? Yes, it is 4. Why? Because when we have rotated 360 degrees, we got it 4 times. That is why the order of rotational symmetry is 4. And for the first time when we got the same figure? Yes, when we rotated through 90 degrees. Now, this angle 90 degrees is nothing but the angle of rotational symmetry. So, children, there is an important point to be understood here, that all the figures have rotational symmetry of order 1. Why? Because any figure if you rotate through 360 degrees, exactly at 360 degrees you will get back the same original figure. So, every object or every figure in fact has an rotational symmetry of order 1, but we consider a object has a rotational symmetry only when the order of rotational symmetry is more than 1, that means at least 2. Got it children? So, that means an object or a figure has rotational symmetry if its order is 2 or more than 2. Got it children? Children, let us see line symmetry and rotational symmetry. Does it exist for a single figure? Let us see. So, equilateral triangle I am going to consider here, and I am going to draw 3 lines as shown, and these 3 lines are what children? Yes, they are lines of symmetry. For an equilateral triangle we have seen already, the number of lines of symmetry are 3. Now, if I rotate this equilateral triangle through 360 degrees, I got it thrice. It looks same as what we have taken. How many times children? 3 times. So, the order of rotational symmetry is 3. That means, a figure can have line symmetry as well as rotational symmetry also. Got it children? But It is not necessary that every figure will have rotational symmetry as well as line symmetry. That you need to remember, children. Now, children, let us see the applications of symmetry in our daily life. So, you can notice the beautiful monuments like a Taj Mahal or say on Eiffel Tower or pyramids, etc. These all monuments, they are symmetric in shape. So, that is why these all monuments, they look really beautiful, children, because they are symmetric in nature. Not only that, children, even in art also. If you notice, all the arts are paintings, if you see, they are symmetric in nature. Then next, this you might have seen during Sankranti and all, right, children, that is Rangoli. So, these are also symmetric in shape. And apart from this, we have the application of symmetry in textile industries also. You might have seen a lot of say dresses with beautiful designs and patterns, right. They all are symmetric in nature. Got it, children? So, children, with this we have come to the end of our bridge course in mathematics, that is symmetry. Now, let us quickly recap what we have learnt in our today's session. Symmetry is that one shape is exactly like the other when it is moved, rotated or flipped. A figure is said to have line symmetry if a line can be drawn dividing the figure into two identical parts, and this line is called the line of symmetry. A figure may have no line of symmetry, only one line of symmetry, two lines of symmetry, or even multiple lines of symmetry. If you rotate a figure about a fixed point by a certain angle and the figure looks exactly the same as before, then it is said to have rotational symmetry. The minimum angle rotation of a figure to get exactly the same figure as original is called angle of rotational symmetry or simply angle of rotation. Some shapes have only line symmetry and some have only rotational symmetry, and some may have both also, children. And symmetry has plenty of applications in our everyday life, as in art, architecture, textile industries, design creations, so many things, isn't it, children? So, children, before we conclude, I would like to give you some assignment to complete at your home and submit to your teacher. Let us see the first problem, children. Write the letters of English alphabet A to Z and find out which have vertical lines of symmetry, horizontal lines of symmetry and no lines of symmetry, and draw any three objects which have a line of symmetry. Now, draw any three objects which are not symmetric. The last question is, find the order of rotational symmetry for the given figures. So, children, I hope you have understood the concept of symmetry and also its applications in our daily life. Children, whenever you go outside, just check out for the images or the figures or the objects that you come across and see whether they are symmetric or not, and just discuss the same thing with your friends and your teacher. So, children, with this we have come to the end of our mathematics digital class. We will meet in our next bridge course class. Until then, goodbye, take care and happy learning.